Hi everyone, welcome to Willington Quay in North Shields. So I've become aware of quite how much of the wind turbine development there is here right on my doorstep. So we've come to Willington Quay in North Shields, right by the River Tyne. You can see South Shields just over here. Let's get that set up for you. And some of the other infrastructure is just right over there on the Equinor side of the plant, where they're making some of the wind turbine blades and getting them ready to install. But right behind me is the Smulders Yard. Smulders are a Dutch company, but they've got a yard here in North Shields where they're assembling a lot of the steel componentry that's going to be part of the new Doggerbank wind turbine site. There's actually like 5, 6 or 7 of these out just in the North Sea. It's over 190 kilometres away from here in North Shields, but about 160 kilometres away from Tyneside, where some of the other componentry is going in, because there's 5 or 6 sites, so there's plenty of different manufacturers that are getting in on the act. Hi there, so this is the 4C offshore map for renewable wind energy. So I just thought I'd show you some of the where these turbines are going that we're just talking about here. So here we are off the northeast coast. So you've got the Hornsea projects down here, Hornsea 1, Hornsea 2, Hornsea 4. And these are the Doggerbank sites. So this one here at the bottom of the triangle is Doggerbank A. We've got B, we've got C and D. And these are the Doggerbank South sites. So if you click on them, you can get a bit of information, but of course they want you to pay for it. So this is the Doggerbank South site, which is said to have a 1.5 gigawatt capacity. And you've got A and B. Doggerbank South, West and East, which are these two. So that's the Doggerbank 2 site, which is the south. And within the one, you've got Doggerbank A, which used to be called Creekbeck A. That is the 1.3 gigawatts that's coming up, and you can see that they've mapped where, when you've had a notice to mariners that the monopiles have been installed, this is their pattern that they've chosen. These are where the wires will be for connecting them into the substation. So that's quite neat to see. And then let me get this right. This is B, which I think is now being renamed Sophia. Although I am a little confused about that, to be honest. But yeah, this is another 1.3 gigawatt station. No, this is Sophia, which was C. Okay, fine. It's a bit confusing, but there we go. We got there eventually. Yeah, this was like Transpec or Lackenby B. So yeah, they kept renaming them all. And you can even see where these are going to onshore. So you can see that some of them are wired to come onshore into Teesside. So this is where the landfall is, over in Teesside, whereas the others are going to be wired in to go into Hull, essentially. I think we call it Lackenby, but essentially Hull, Hornsea. Here you go. Into the Lackenby station here. So just a little bit of a difference is where, although these wind farms are right next to each other, they are going to be wired in slightly differently, and these are the Doggerbank D sites over here. So yeah, perfect. Okay, right, let me know if you have any more questions, and then you can see some of the Dutch sites over here. And currently in the news is the fact that Ørsted have pulled out of Hornsea Project 4, I believe, because they're concerned about what's been called wind theft, or essentially what would be the wake. And you can see, because these two projects are so close to each other, if you have a easterly breeze, that these turbines are going to harvest the wind, and there's going to be a lot of wake by the time it gets to here. Not that there's a predominantly easterly wind, so the wind's obviously going to come from 360 degrees and will come from the south, and they won't get any wind theft or wake, or very little. And it'll come from the north, and they won't get any. It'll come from the west, and they won't get any. But they are concerned about a southeast wind and losing out on some wind, or perhaps they haven't been able to achieve the prices they wanted, etc., etc., and the government wouldn't allow them to claim back for any reduced power that they perceived they were getting. So they've currently pulled out, which is a big gap in our offshore wind plans. It's very disappointing by Ørsted, but we will see what happens and if someone picks it up or if they're just after more money. Okay. In on the act here, but right behind me I've got some absolute ginormous steel infrastructure that I wanted to show you, because these are the transition pieces. So as part of an offshore wind turbine, you've got quite a few different pieces, but we'll break it down into little chunks. So you've got the long steel monopile foundation that gets driven into the seabed and becomes the base, the steel and concrete base, which everything else goes onto. But rather than just having a similar diameter turbine shaft go on top of it, you need a transition piece. So that's what I've got right behind me, so I'll show you those. It'll be a wider diameter it'll sit on, and it'll allow an interconnect between the long shaft monopile into the seabed and the long shaft up to the turbine where the nacelle, where all the gears and power generation equipment is, and all the blades will get attached onto. So the transition pieces are this middle piece that transitions between the foundations and the turbine. So let's have a little look at them. There's also some other equipment here that I'll show you as well, which is the out to sea converter stations that they've got, because they're going to transmit their power back in ultra high voltage DC cabling. So let's have a look without further ado right behind us, and if I perhaps zoom in a wee bit, you can just see how tall and imposing these things are, and these ginormous cranes that they've got there. So these huge yellow bits of equipment I've got over here are clearly the transition pieces, and they're absolutely ginormous. And the yellow will be a huge powder coating or paint coating. We'll be using industrial paints, isocyanates or something really effective, but not very good for anyone who's applying them. So I'm sure they take all the precautions that they need to. And then over here, you might be able to just about see these grey structures above the trees. Over here we've got, if I just move to the other side, we've got these subsea converters, or above sea converters. They'll have foundations subsea, but they're going to be above sea to stay nice and dry, because that is key with electrical equipment, right? Absolutely impressive, ginormous yard, and it's great to see local green jobs replacing some of the offshore oil and gas industry, which was a huge employer for, say, Teesside and Tyneside here in the past. But we're all going to be transitioning to these green jobs, making, painting and installing and maintaining things like offshore wind turbines. So this is an absolute delight to see. I'm right by the Pedestrian Tynetunnel, and we're going to head under the Pedestrian Tynetunnel, and we're going to go see the Equinor, part owners of the wind turbines, the wind farms. They're a 40% investor. I'm going to go see their factory on South Shields. So I'll just walk around the corner. I'll show you some more of these subsea converters, but we'll get into it later when we see more. Okay,
hi
ciao.
Guys, so a really good other view of all these transition pieces. You can see they're in rows of 4, and we've got 1, 2, 3, 4, 5, 6, 7, 8 rows of 4, and you've got some further ones down the bottom. And if you just look to our right here, you can see one of these ginormous foundations for to hold the subsea station high up off the seabed and off and out of the waves. And you can see how you've got the unpainted, untreated, oxidized steel at the bottom, and then you've got the yellow powder coated steel at the top, which is just sort of fascinating to see, and all the different cranes and apparatus they've got for delivering these things. And so sometimes you're lucky and you've got the huge ALS boat to deliver these out to sea here. It's absolutely fascinating to see. So without further ado, let's pop on to South Shields and we'll see the alternative stuff down there. Okay, ciao. Right, so while we're walking to the Tynetunnel, I thought I'd tell you a little bit about the Doggerbank wind farms. They're in several phases. The first phase, I guess you've got the A, B and C phases. So Doggerbank A and B are both going to connect to the Creek Beck converter station, which is being built in Humberside. And Doggerbank C is going to come to the Lazenby connector station, which already exists in Teesside. It's going to onshore through one of the beaches in red car and come over. All of them were originally stated to have about 97 or 100 turbines installed, and they were all going to be 13 megawatt Siemens Gamesa turbines, which have recyclable blades, and they've been modified slightly because each phase is going to be 1.2 gigawatts. They've been modified slightly because Doggerbank C is going to have less turbines but more powerful. It's going to go for 14 megawatt turbines, so slightly bigger. All of them, the nacelles are 150 meters up in the air. Correction. So the 14 megawatt turbines are going to have a rotor diameter of 222 meters. So that's the full length of the wingspan, if you like. And if you can imagine, if your blades are 114 meters long to be able to achieve that, then your nacelle has got to have a good amount of ground clearance. So it's 150 meters up in the air, which is absolutely fabulous. So the swept area of those blades, if the area of the circle's diameter when these blades are spinning round, is 39,000 meters squared. Absolutely huge. And the power that these things generate is based on that swept area. So the bigger that you make them, the harder it is, because your blades have to be stiffer, stronger and heavier, but the more power you create. It's absolutely stunning. And we don't know what the limit of getting these turbines bigger and bigger and bigger. A lot of the onshore ones you see might be 1 megawatt, might be 2 megawatts, and there's limits to how big you can make those because you've got to get around the corners on a road. Even on motorways, which are long straight things, you've got to get off the exits and stuff like that. So there's limits to how big onshore ones can go. The limits for offshore is all about the material density. If you want to know more about those, why don't you check out Engineering with Rosie's channel, who used to work in this sector and knows a lot more about this than I do. So if you want to learn more, check out Engineering with Rosie. I'll put a link to her videos on this now. One bit of news for the Doggerbank A wind farm is that all the monopiles are in place, all the foundation, all the T-pit pieces are in place, and 52 of the 95 GE 13 megawatt wind turbines have now been installed. So some are the Siemens Gamesa in B and C in Sofia and Doggerbank South, and some are GE. So Siemens Gamesa are a Danish company, and GE General Electric are an American company. So you've got competing wind turbines going in at different parts of this wind farm. So the three I've mentioned, the Doggerbank A, B and C, 1.2, 1.2 and 1.4 gigawatts of power is going in. So add all those up, what have you got? You've got 3.8 gigawatts. But we can't forget Doggerbank South, which has got an A and a B, and we can't forget Doggerbank D, which is further further to the east, all adding up for a total of 6.8 gigawatts. And so, you know, competition in the industry for supplying these turbines will keep costs down and make sure that people are being competitive. Right, so we're almost at the Tynetunnel now. I haven't been able to take the nice off-road way, cycle path, because it's currently getting repaired or dug up for something. So hopefully the sound quality has not been too road noise affected. Other good news about the Doggerbank wind turbines is that all the monopiles are now installed at Doggerbank B as of the end of April 2025. These wind farms have got a scheduled turn-on date by, for A, end of 2025, had been delayed from start of 2025, but they had a lot of bad weather when installing their monopiles. But it's great to see that B, who's due to come on in 2026, has finished its monopiles and now be doing its transition pieces, and both the intercable arrays have all been installed, so that's absolutely fantastic news to hear. So what I didn't realise is that the pedestrian, the cyclists have separate tunnels. I don't know if in the past when they first built it, it was a northbound and a southbound one, but apparently what it was a lot of people from South Shields were using this in the 60s to commute to work on the shipbuilding, which was all on the North Shields docks. So that's quite interesting. You can just see just quite how long this tunnel is. It's absolutely ginormous. Down here, let's even that up a bit. I was just talking to a cyclist going down the lift who was saying that he was born when this was first built. He was only about 1 or something when it opened, and he met a few people who did the building. The road Tynetunnel has got a north and a southbound now. And the newer version is like a straight tunnel, whereas the oldest version does a little loop as you come up on the North Shields side, which adds about a mile on the journey. It's a bit of a pain. But anyway, I will see you when we're at the Equinor factory, just to see what we can see down there. I don't know what they'll have. Equinor are a Norwegian company who were primarily in oil and gas, but they've divested a bit and they've diversified into renewables, and they're 40% owners of at least the Doggerbank A site. All of these different A, B, C, South, which is in an east and a west, and in Doggerbank D are all owned by different people, different bids into the CFD auction scheme that the UK government runs. At the moment in the UK, we've got about 15 gigawatts of offshore wind, out of a total of 30 gigawatts of total wind capacity. The offshore component will have much higher capacity factors. A capacity factor is the difference between the nominal wind turbine's output at peak wind speed, or at the best wind speeds, as you'll see on a graph from 0 to up to their optimal running speed, that the energy that they can get is proportional to the speed of the wind. But before you get there, and then you sort of mellow off, where they'll change the pitch of the blades to suit really high wind speeds, so that they don't spin far too fast and knacking their gears, but they can still be going at certain wind speeds, and then they have to cut out if it gets to, like hurricane or 100-mile-an-hour winds. Okay, see you in the next one. Hi guys, we're at the Pedestrian and Cyclist Tynetunnel, and I hadn't realised that they've closed the escalators. So we used to just use the steps which were here and just lug our bikes on our shoulders, but they did make these new escalators, but now there's some lifts around the back which they're saying to use instead, and they've closed the escalator, presumably because it's cheaper to just run one thing and not have to maintain two things. So let's go have a look at the lifts, which are just around here. And this will save me from spending £2.50 in the bloody tunnel every day. So let's go and check how we get down here. Hi everybody, so welcome to Equinor and the Doggerbank Wind Farm factory here in the South Shields dock. We're just to the left of the Tyne dock, and you can see that this factory has got renewable energy at its heart. Not only is it producing the world's largest offshore wind farm equipment here, or at least some of them, it is covered in solar panels, ensuring that as much renewable electricity goes into the manufacturing of these and the powering of the factory. And I can already see all the staff's EVs in the car park as well, which is fabulous to see. And you can see some of the large infrastructure that they're going to be installing from here. You've got this huge crane that they're going to be loading the offshore wind farm turbines onto, and delivering some of the heavier equipment there as well. So let's pop around the corner and just see if we can see any more of the excellent infrastructure. Hi again everybody, so we're right here on the very far east of the Tyne dock. It's actually within the Tyne dock compartment, so you can't get close. I'm on the road just by it, and you can see the Equinor factory and what is it? It's the operations and maintenance base and the Doggerbank wind farm factory there. And if you just look slightly to your right, you can see the DFDS ferry to Amsterdam here, so you can take all your low carbon holidays right there from North Shields. And it's just great to see some of the engineers arriving. They're going to be going to help install these wind turbines and maintain them, change the oil in the lubricant gears. Now, one of the troll comments I often see online about wind turbines is that they use so much oil that you might as well just be burning oil for power, but clearly that's just so foolish. Clearly a tiny bit of lubricant oil, or even gallons and gallons of lubricant oil, is going to be vastly lower than consistently burning oil for power and instead just capturing some free wind energy. It really is one of the troll comments that gets me the most. Some of the other funny ones are that the plastics in the blades would be more carbon emissions making a turbine with the steel, with the concrete, with the plastics, with the oil lubricants than can possibly ever be offset by producing wind turbines. And it's just such a joke. How can anyone really believe that? With all the amount of power that these things manage to replace. And they've got such a high capacity factor of above 50%. Equinor have already made Hywind one of the first floating wind farms in the UK, and Doggerbank is predicted to have between a 50 and a 60% capacity factor. Don't know if that's over generous or that'll turn out to be true, but we are lucky here. If I just step up a wee bit and if I zoom in for you, you can just about see one of the monopiles there. So that's a 40 metre long, huge, massive steel shaft. It's got a yellow end at the left there, just by the crane, and that'll stick out in the water. And so that's where the T-pieces, the transition pieces we saw earlier, are going to attach to, and the right-hand side will be driven into the seabed to make the monopile foundations stick like glue. And you can see more of the solar panels on the Equinor and Doggerbank factory there. And here we've got the hybrid-powered Grampian Tweed installation vessel here. Now, actually, is it an installation vessel? It doesn't look big enough. I wonder if the Grampian Tweed is actually one of the vessels that scout the route for the cable. It might be a cable laying ship. It might be one of the ones that provides all the ultrasonic and bubble protection for when they're forcing these monopiles into the ground. There's concerns that the sound from that could really damage fish's ears or drive fish away, etc. So one of the things is they lay an innovative bubble cordon around the seabed and allow these bubbles to come up and dampen the sound wave's ability to get through the sea and damage fish's ears. Or it could be a geoengineering, geophysics surveying vessel. So I'll look up the Grampian Tweed and I'll provide you the information below there. But yeah, just absolutely fantastic to come and see this installation site, and I'll continue around the corner to see if we can see some more. Guys, so now you've got a closer view of where those monopiles are on a barge out in the river on the north side, and you can see the eastern view of the Equinor and Doggerbank wind farm operations and service base. The Grampian Tweed is actually a service operation vehicle, so that's where they're going to be doing all the servicing. It's where a lot of the crew, the offshore crew, which will have all been trained in oil and gas, but these skills are very useful for offshore wind turbines in terms of getting on and off these rigs, safely doing oil changes and other technical tasks out there to sea and coping with the environment. And you can see on the right there the DFDS ferry to Amsterdam, where you can take your low carbon holidays. So yeah, really glad I came out over here to see the site, see the monopiles, show you the T-pieces, and it's a nice little complementary adjunct to the Siemens Gamesa factory down in Hull, which is doing a lot of the other offshore operations in the UK. The Doggerbank ones are going to be made by GE, not Siemens Gamesa, but still, it's great to see the future in action and how our future energy needs are going to be supplied by these wind turbines. Now, one of the things I noticed from the Equinor website is that Doggerbank could provide at least 25% of the energy needed if every single car and HGV in the UK was electric. So this thing is going to be absolutely huge. And they're only including the 3.6 gigawatts of the A, B and C. They're not including D, and they're not including the 2 parts of South in that calculation either. So electricity demand in the UK is predicted to double, if not triple, or 2.5, somewhere in between. But we really do have the solutions for this. And one of the reasons that I'm so keen that this comes online as soon as possible, hopefully they get some nice calm seas so they can install these quickly and efficiently, is because Drax is in Yorkshire. And half this wind farm is going to be connected to Yorkshire down in Creekbeck in Hull. And so hopefully this can turn the bioenergy, the burning of new forests at Drax in Selby in Yorkshire, and turn that off and have it replaced with wind. And then Drax can just be a load following power peaker, and not as a consistent base load power, consistently burning trees from Canada, which is obviously not renewable. And they've had massive fines recently for being slightly economical in the truth, shall we should say, about where their wood is supplied from. And the government have warned them about it and given them a bit of a ticking off. So anyway, thanks for that. Thanks for sticking with me. Hopefully this has been interesting, and if you want to know any more facts about offshore wind, please do check out Engineering with Rosie. And if any of you know better than me and want to tell me anything more about the Doggerbank site here in North Shields, or the Siemens Gamesa factory in Hull, or anything else, please just leave a comment below and let's educate everyone. I'm super excited about this wind farm turning on later this year, or at least the first third, and we'll wait to see how the rest do. Okay, I'll see you in the next one, guys. Bye.
So this was my first attempt at a video like this, so let me know what you think. Has it been interesting? Should I stick to cars? Do you want to know what's happening with the heat pump? Or did looking at some of the renewable energy infrastructure roundabout in Tyneside interest you at all? So let me know if this was just a big rambling waste of time or if this was in any way interesting. Okay, thanks so much for your feedback, guys. What was the sound quality like? What was the image quality like? I can record at 4K, 2.7K, 1080p, but I can only edit at 1080p, which is a bit frustrating. Not sure I could be bothered paying for a 4K video editor, but if you know of a really good one, then let me know, and we might be able to improve things. But I don't have a graphics card on this desktop computer, so it might take a while to process. But anyway, let me know if it's been nice, or if there's anything else you want to know about. Okay, ciao.